The title is quite ambitious, how to build big, fast and mobile maps. Big means a lot of place marks, complicated figures to draw on the map. And fast, of course, it's you don't want to wait 30 seconds for your map to be available, and especially when you're on mobile. So, as I mentioned, KML can be the first, oops, thank you. KML can be the first solution to help you on that matter. If you have, let's say, 20,000 place marks that you want to display on a map, what you can do, obviously you don't want to display them all at once and download them all at once. You can use one KML object, which is called network links. So the network link is something you describe in KML, so in XML, and it has a name, a description, and then it has a link tag. The link tag says the content of that network link is located over there. And so you call any kind of URL to get actually that content, and it will get replaced. The nice thing is that that URL may include some data to give you a hint about what you should display. So let me show you an example. I loaded here one network link, and the network link will be updated when I stop flying. I will have 1 point here that comes back. So what happened? When I stop flying, the network link calls the server with a few parameters. So the parameters are the bounding box that is visible on the screen. So when you fly in and you stop flying, the network link automatically refreshes with those parameters that are passed in the URL. So this means if you have 100,000 place marks to display, then you will be able to only show the fraction that is visible on the screen. And whenever you change the place you're looking at, you get another fraction. So that's the first method if you want to display a lot of place marks. Yeah, so that's really the first one to use. So network links, as I said, so there are two ways to... The other advantage of the network link is that you can get up to date. That used to be the case when you had Google Earth. You were downloading that network link once, and then whenever you open Google Earth again, it would refresh. So that's the other way you can use the KML, so that the content keeps fresh. If you have a news feed, for instance, that is geolocalized, you can update the content of that news feed every 2 minutes, 3 minutes, it depends on your server. But the main feature is really to be able to send back to the server the place you're looking at and the content that you actually need to be displayed. You can change a little bit the URL format as well to send more information about the client version, how the user is located on the surface of Earth, and the bounding box of, obviously, of what you're looking at. That's another feature. It looks like what Leonid showed for Yandex. We have the same. Yay! Let me show it to you. It's called My Maps. How many of you know My Maps? Okay. So My Maps is really the most simple way to create a map, because you just go on the My Maps tab, create a new map, and then you can add any kind of stuff and populate it with no matter what. So that's not a big deal because it's just a basic mashup. So you store everything on the Google side. So whatever you store as a content, every content you store in those bubbles, every image, etc., gets indexed right away and can show up as a result in a result list. But the nice thing is that we just introduced something new, which would be something like this, for instance, which shows a lot of place marks right away. So what happens after 200 place marks? Now the place marks get integrated in the tiles. So things will get much faster because you won't have to do all the JavaScript and the DOM manipulation to create all the Java place marks, but everything will be in the tiles right away. Just a little bit like if you're using the photos. You see, it's quite fast. It's because those images are clickable, but they are integrated in the tile. So we just send one tile with the little pictures in there, and it's clickable. So that's really faster than just using the regular map tiles and then do the JavaScript to add the place mark at each location. So this is what we just implemented in My Maps, which means that if you have a huge map that you want to serve in an ideal way, you just have to upload it into My Maps, and it will get rendered in the best possible way. And then you can embed it in your website, for instance. That's really for the lazy developer. I don't encourage you to be lazy, but don't look for trouble if you can avoid it. So that's really nice. And the other nice part of My Maps is that now we have the Maps Data API. So the Maps Data API, how many of you know GData? Yeah. So GData is the protocol we use at Google to update any kind of objects on Google properties. So you can create a spreadsheet using GData. You can do a search using GData. You can do read your calendar using GData. And now what you can do is use GData to create your own My Maps programmatically. So you can build your own application and publish everything through this API in a My Map and have it render in the best possible way. So the way it works, it's quite simple. You get connected with a Google account. So to get connected with a Google account in GData, you have several ways. You enter your user password, that's for the desktop application, or you use OAuth or auth-sub, which are two protocols which send the user back to a Google login screen, and if it's connected successfully, it sends it back to your application with an authentication token so that you can get access to that content. And once you're in there, then you will browse through your existing maps, and for each map, you will retrieve KML snippets for each feature that you created in that My Map. So it's an easy way for you to really create everything programmatically and have it stored in My Maps, so you don't have to take care of the storage, indexing, presentation, anything. You just have to be creative when you create that content and then update it using your application. So you can put points, line strings, polygons, and the place marks can have those features as well. So it means that you can create any kind of icons, any kind of info bubble. So we already saw that slide, so I won't take too much time on it, but yeah, the main idea is still the same. Whenever possible, try to get big chunks of images that can be used right away, that's static maps, and then use the fastest JavaScript libraries available. So why would you develop an application in a browser, even on mobile? So the main answer is that if I want to have an application that runs both on iPhone and Android, for instance, well, the web application is a good solution because I have to develop it only once. There are plenty of professionals who are paid to be sure that something that works on one device is working on the others. So all the cross-platform issues are taken care of. And of course, if you build a mashup for mobile, then you can expose the same one on the web as well, because it's still the web. There's no download, of course, and if there is a bug, which can happen, then you can fix it and nobody will notice. That's a nice thing. So, when you start building an application for a mobile browser, then you have several issues that you have to address. The first one is the screen size. I would say the screen size and the size of your fingers because obviously you cannot put as many links as you would on a web interface. User interface and interaction, of course, it has to be much more useful, right away, obvious, etc. Speed is really a main problem. We will get into that after that. And use cases. It's okay to have a desktop or laptop browser getting on a web page and browsing around because it's quite easy. But on a mobile, any additional move is just an extra pain, and you're losing confidence in the application. So, speed is important. One thing that we noticed is that it takes 10 times more time to parse JavaScript on an iPhone Safari browser or an Android browser than on a laptop. You don't have as much cache as you would on a laptop as well, and every millisecond matters. So that's really the main thing, is that JavaScript is slow, and fetching content remotely is a pain as well, because it's on mobile. So serving that data can be a cause of latency, because it takes time for your server to provide you with the content. Download time is obviously a problem, especially if you don't have 3G networks. And then the JavaScript parsing time, because those devices are not as powerful as your laptop. So this should go away with the time, but for the moment, it really makes a difference. So if you look at what happens when you load a web application using the JavaScript API, there is a lot of stuff being downloaded, the tiles, the JavaScript code, etc. So this is the way it works. When you build a mashup using the JavaScript Maps API, the first thing you include a call to load what we call the bootstrap, which will be just an initial set of JavaScript lines that will prepare things and call for the loading of the library after that. So the bootstrap takes 2.5 seconds on average, and then it takes 3.1 seconds to have the main library loaded, actually. Then you do your stuff, you load your place mark, you start to create your objects, etc. Once you set the center of the map, which means you have the map in a div, and you say, I want to display Moscow. So you set the center of the map. Then we start to download all the tiles, the images that we display, and this can take up to from 3.8 to 4.6 in the time frame. So that's 4.6 seconds to have a map ready to run. So this may seem a lot, but it's even worse on a mobile, because it takes 9 seconds. So compare it with the 3.1. It takes 9 seconds to have the main.js up and running. And once it can take up to 18 seconds to get all the tiles, because you're on a poor network, etc. So why is that? The first reason is that we load tiles, like everybody does when you display a map, so small images that are part of the map. And what happens is that those small images take 202 kilobytes, whereas if you have one big chunk of the same map, it can take 78 kilobytes. So that's the first thing to address. It's instead of loading several files, because each file will have its delay, etc., you just load one big file with everything in there. So this is why we have the Google Static Maps API, where you can, of course, you display everything in a URL, all the settings of your map. So that map is just referenced by one URL, which says, put me 3 place marks on the map, center it on New York or somewhere else. And so this is the URL of one big picture. So instead of loading all the tiles right away, you load that picture, which takes less time, and you already display a result to your user, and then you can start loading the tiles for the real interaction of the map. But you initialize the map with some static image that will appear quickly, so that the user doesn't have the feeling that he's waiting for something with the circle. We added in the static maps API, we added some parameter so that if you load it on a mobile, the tile is actually different from the one you load on the desktop, so that it's even easier to read, lightweight, and of course better for mobile usage. The other reason is that 220 kilobytes of code is a lot of things to parse if you have a CPU that is not that strong. So the people in charge of the JavaScript Maps API decided, okay, so let's put some code at the end of the process and load it as needed. For instance, if you don't display any polygons, you don't have to load all the code that is taking care of the polygons. The problem is that the version 2 of the JavaScript Maps API is synchronous, so it more or less is impossible to do, to defer the code at the end of the process. It's really just, everything has to be there right away because it's synchronous. So that's why version 3 has been implemented and designed. So the download size is now 35 kilobytes. So it's faster to load, faster to parse. And by default, it does what I just mentioned, which means provide you with a static map of your viewport first, and then replace it with the tiles as needed. So the whole V3 API has been designed for mobile usage to be fast, fast, and fast. So if you look at version 2, the 9 seconds to get the main.js running, we are now with 2 seconds. And the tiles, we switch from 18 seconds to 7 seconds. So quite an accomplishment. So how does it work? So the first thing, as I said, it uses static maps. The other thing that we introduced is really the MVC architecture, which is model view controller. So this means that the model is loaded right away. And if you start to use one of those objects, then we will load the views that make it possible to render a place mark or a polygon or a line. So this means that you just load the definition of the objects that are available in the map, and then when you try to use the map, then it will download all the stuff you need to actually manage, display, and control that map. So that's the way it works. It's really just load the definition of the objects you're going to manipulate, and if you start to manipulate one, retrieve the JavaScript code needed for it. So this means you start with a small footprint, and then you increase it by needs. So what we expect with that approach as well is that as we will be adding new features on this API, the initial footprint should remain the same, more or less. So it shouldn't degrade over time over a number of features. And from an internal point of view, it's easier to debug this way as well, because every object has just setters and getters, and they have a view, and they have different views that can be used, applied to them, and controllers. So what else in that version 3? Of course, the support of Chrome and iPhone Safari. There's no more license key. In version 2, you had to provide a license key. That's over. It's not there anymore. The other thing that was cumbersome, if you want to display all the controls on the map, the arrows, the zoom levels, the different buttons, etc., you had to define everything individually. Now it comes bundled, and you can opt out for some options. So that's faster to load as well, because it's predefined. We changed a little bit the geocoding mode, so that's a nice thing as well. When you want to geocode an address, you can say, geocode that address for me, but please stay in the map I'm showing. If I'm looking for Paris without mentioning anything, the API may come back with Paris in France and Paris in Texas. I don't want Paris in Texas, so if I just have a map over France, I can say, okay, let's stay in that region code or on that viewport. Driving directions, it used to be just mixed between the calculation of the routes and the display of the routes. Now it's different. You can call the service, retrieve the object. Then you have a few views to really show the result, but you can process it yourself as well. So for the moment, not everything that is available in version 2 will be in version 3, but we are working on it. So I really invite you to have an early look at the version 3 API because it's really worth it. You saw the figures on the loading time, and it's probably easier to manage as code as well. So yeah, that was it. So on mobile, the thing you may want to do if you have advanced handsets, use JavaScript API version 3, static maps for the other handsets. And if you want to build application, you still have those two libraries available for iPhone and Android. So I had a few more considerations, for instance, on displaying polylines. So if you want to draw something on a map and it's quite complex, it can take a lot of time because you will be building DOM nodes to create everything, and it's probably not that easy. We have something called encoded polyline, where what you say is you define the points, the first point actually, and then you give the delta to get to the next point. And for each point, you can say, show that point for this group of zoom levels, which means that if I'm really high, there's no point in making 20 points around one corner, because I won't see it. So I would keep just the straight line if I'm high in the sky, and if I'm close in the ground, I will get more details. So that's embedded in what we call encoded polylines. It has been there for a while. It's quite complicated to automate because you have to encode everything in a really short, condensed way, but it's really faster than using the standard polylines, if your polyline is big, of course. Displaying many markers. You may have a map with a lot of markers to display. Keep in mind that people won't be able to read it if there are more than 50 place marks. And then you have a whole branch of ways to cluster those things. The first method was the marker manager, where you could display for each level of zoom what you wanted to display. That's an easy one, and it's implemented by default. There are plenty of things out there which make it possible for you to, for instance, make clusters around, yeah, we'll talk about that later on, yeah. This one. So for instance, this will cluster by region. Any place mark is grouped by region, and then you just display for each region the number of place marks you have, and then when you click on it, you have the detail. So it's always the same when you have loads of place mark to display. Just find an adequate navigation that will show things progressively. That's another one. Using a grid, so it just, if the longitudinal latitude is in that square, then add it to that centroid. There are more sophisticated stuff, like the k-means algorithm, which is a clustering algorithm, which will group the close points together to just show one. So this requires a little bit more work, but there are plenty of resources out there to help you do that. Yeah, as I said, we're running kind of out of time. I'll be outside during the next hours, and I'm ready to answer any kind of question you may have.